What is cloud computing? When talking about the cloud, the next thing that associate with it is cloud computing. The term refers to the computation and manipulation of big data stored in the cloud. There was a time when there was no such big storage and people used to store their data in their personal storage. So before the cloud, each individual service used to have their own dedicated server. Each had its own hardware requirements. Software requirements also had its own importance. Then comes the security levels for the data, which required the security features. And obviously, to run this setup, the electricity is also a main essential. All this accounted for higher costs and more investments. The term cloud computing refers to manipulating, configuring, and accessing the application online. It offers online data storage, infrastructure, and application. Cloud computing is a combination of both the software and hardware-based computing resources delivered as a network service. Cloud computing is the on-demand delivery of IT resources over the internet. Cloud computing is defined as storing and accessing data and computing services over the internet. It does not store any data on your personal computer. It is the on-demand availability of computer services like servers, data storage, networking, databases, etc. The main purpose of cloud computing is to give access to data centers to many users. Users can also access data from a remote server. The goal of cloud computing is to allow users to take benefit from all of these technologies without the need for deep knowledge about or expertise with each one of them. Cloud computing uses concepts from utility computing to provide metrics for the services used. Cloud computing shares characteristics with client-server computing, refers broadly to any distributed application that distinguishes between service providers, means servers, and service requesters, that is, the client. Computer Bureau, a service bureau providing computer services, particularly from the 1960s to 1980s. Next is the grid computing, which is a form of distributed and parallel computing, whereby a super and virtual computer is composed of a cluster of networked, loosely coupled computers acting in concert to perform very large tasks. Fog computing, distributed computing paradigm that provides data, compute, storage, and application services closer to the client or near user edge devices, such as network routers. Furthermore, fog computing handles data at the network level, on smart devices, and on the end-user client side, for example, mobile devices, instead of sending data to a remote location for processing. Mainframe computing, powerful computers used mainly by large organizations for critical applications, typically bulk data processing, such as census, industry and consumer statistics, police and secret intelligence services, enterprise resource planning, and financial transaction processing. Utility computing, the packaging of computing resources such as computation and storage as a metered service similar to a traditional public utility, such as electricity. Peer-to-peer, a distributed architecture without the need for central coordination. Participants are both suppliers and consumers of resources, in contrast to the traditional client-server model. Cloud sandbox, a live, isolated computer environment in which a program, code, or file can run without affecting the application in which it runs. Cloud computing exhibits key characteristics like agility for organizations that can be improved, as cloud computing may increase users' flexibility with reprovisioning, adding, or expanding technological infrastructure resources. Cost reductions are claimed by cloud providers. A public cloud delivery model converts capital expenditures to operational expenditure. This purposely lowers barriers to entry, as infrastructure is typically provided by a third party and need not to be purchased for one-time or infrequent intensive computing tasks. Device and location. independence enables users to access systems using a web browser regardless of their location or what device they use, for example, PC, mobile phone. As infrastructure is off-site and accessed via the internet, users can connect to it from anywhere. Maintenance of cloud computing application is easier because they do not need to be installed on each user's computer and can be accessed from different places. Multi-tenancy enables sharing of resources and costs across a large pool of users, thus allowing for centralization of infrastructure in locations with lower costs, such as real estate, electricity, etc. Performance is monitored by IT experts from the service provider, and consistent and loosely coupled architectures are constructed using web services as the system interface. Availability improves with the use of multiple redundant sites, which makes well-designed cloud computing suitable for business continuity and disaster recovery. Cloud computing accounts for many of the benefits linked to it. Speed is one of the key benefits, as you need to wait as little time to upload, fetch, query, or process your data. You do not need to buy expensive hardware in order to set up your own warehouse. Thus, another benefit is the cost reduction. As you grow with time, data also increases. Hence, the other great feature is the scalability, which allows you to scale your databases. The ease of access makes it easy and readily available throughout anywhere you need. Last and for all is that you do not need to be concerned about the security of your data, as the service provider themselves look after all such issues.